Hello students, welcome back to our science class. My name is Anjali and today we are going to continue our chapter 11. So I hope you all are fine and safe at your places and doing good. So students, now you have to observe something, okay? The first thing which we are going to see that the image about, and just share your observations, okay? We have an iron nail and a hammer, okay? Which you usually might have seen at your homes. So students, what do you think that to beat a, you can think of this is an iron nail and this is a hammer, okay? And if we have a, you can say that the sharp tip of the iron nail or the back end, right? So like this, we press it in the wall, right? To make it so that it's stuck on the wall or any wooden plate, right? So students, what are we actually doing over here? Yes, we are beating it fast. We are applying some kind of force, right? Force towards it. And students, what if I inverse this iron nail and bring the pointed edge towards yourself and try to hit the pointed end and just apply the hammer towards this side. So what do you think? In which case it will be easier for me to make this iron nail stuck on the wall or on the wooden plate? Yes, students. You can think of your examples from which you might have seen at your homes also. Yes, you must be saying that we always beat the hammer towards this part of the iron nail, which is the rodent one, right? And this part we stuck on the wall, right? Which is we are having. So basically, students, we are applying some kind of force over here, right? So the type which we are going to discuss today is about the relating with the some kind of forces involved over there also, but in terms of the pressure, right? So students, let's discuss today about the pressure. So pressure, students, we are going to discuss the concept of pressure first. What do you understand? Here you can see the iron nail. So some kind of pressure we are applying on this area, right? Yes, this is the broaden area and this is the thinner area. So students, basically the force acting on the unit area of a surface is called the pressure. So you can say that force on unit area is what called the pressure is. So you are saying that the area over here we are having two types of area. One is the large area, one is the pointed area, right? Which is the unit area. So we are applying pressure over here. So you can say that force, we are applying force over here in this amount, in this area of the iron nail, right? So this applying of force in this area is called a pressure. Is termed as the pressure. So now students, if you have to write the pressure in terms of the formula, so how will you write? Let us represent pressure by P and force by F and area by A. Okay. So what do you think the pressure is what? Since we are discussing it is that force acting on the unit area. So the pressure comes out to be, yes, force per unit area. Which is the, let me write over here also. Yes. So in the denominator what will come? Yes, the area will come in the denominator, which is, you can see that the pressure is the force which we are applying on that object on the per unit area of it. So this is the formula of the pressure. So area is always in the denominator of this expression of pressure which you have seen. Okay. Now students, the smaller the area, the larger the pressure on a surface of the same force. Because you have studied this relation of inverse proportion and the direct proportion, right? In your the 7th class, I guess, in the maths. So there, if you say that one pressure is here and the area is in the denominator, so pressure and area are inversely proportional to each other, right? The smaller the area, the more will be the pressure. The more the area, the less will be the pressure. So students, what do you think in case of that iron nail? Yes. In which case the pressure will be less. If you beat the hammer, yes, this is the iron nail students, and we are taking, you can think of this is the hammer, okay? Now what do you think that where it will be easier for us to put this iron nail on the wall or on any wooden plank? You can write this is iron nail, okay, and this is hammer. Yes students, so pressure will be more in which case? Yes, wherever the area will be less. So area will be less over here. You can see if we are taking the hammer over here, so the pressure will be more, and the pressure will be less when the area will be more. This like this you can think. So area of the pointed end of the nail is much smaller than its head. You always say that, you can see that how area is so small than the head of this iron nail, right? So it produces a pressure sufficient to push the pointed end of the nail into the wooden plank. So what is happening? Pressure, it producing the sufficient pressure, students, the same force to push the pointed end towards the nail or into the wooden plank. Right? I hope you're clear with it now. Now students, it's your time to think and answer, okay? Something you have to elaborate upon it, right? That why do you think, first of all, what do you see? Yes, you must be seeing that there is a bag, school bag, right? Very good. So if I ask you that, what do you think the school bags they are given with the broadened straps? There large broadened straps are there in the bag. Why not only the very thin strips they give in the bag? Yes, students, what do you think the reason for it would be? You can relate it with the concept of pressure as we are discussing. Yes, very good students. I hope you have got the point. Since that pressure, what is the formula of pressure, students? Yes, force per unit area. Okay. So what do you think that to carry the bags on our shoulders, the pressure on us should be the less, right? It should be less. So that, what don't you think that if pressure would be less, so we require more area? Yes, we require obviously the more area because they are inversely proportional to each other, right? So students, if pressure, if area, you can say area will be more, so the pressure will be less, right? If area will be less, so the pressure will be more. So what do you think in these two conditions? Now can you explain that why their bags are provided by the broadened straps? Yes, because the straps, broadened straps are having the more area. So if area will be more, the pressure will be less. That is why they are provided with the broadened straps. So students, like this you can think of the concept that how the pressure and the area they are relation with the daily life things also. One example which I have already discussed with you. So now students, it's your time to define what is the pressure. Yes, you can define by at your own places, or you can write your answers in the comment sections. What is the pressure? Yes, pressure is defined as the force acting on an object per unit area. Very good. So students, if area will be more, so the pressure will be less or more? Yes, the pressure will be less. Very good. So now let us see what is the formula of pressure. So students, you have to write down the formula of pressure. What is it? Yes, you can write it. Meanwhile, I will also write it on the board first of all. Are you done? Okay, yes, you might be done. So as we are discussing the about the definition, from the definition itself we can get the formula of pressure, which is, yes, very good. It is force upon area. Area is in the denominator, right? Yes, very good, students. So now I am going to show you few more images. Okay, you have to see what is happening with it. Actually, I have taken a glass rod, right, and a balloon, and I have attached that balloon with this glass rod and filled some amount of water in it. Okay, you can see that how the balloon is attached and the water is filled in the tube. Okay, now I'm going to show you another image. You have to describe it also, like you can compare it, what is happening, is it the same or not? Yes, students. So have you seen something? Yes, there is some kind of difference you must be finding out, right? The balloon got broadened up, right? What else difference are you finding? As I fill more and more water in the second glass tube, students, so you can say that more water was there, so the balloon, it got widened up, more widened up, right? You seen in the first case that in the first case or in the second case the water is more, in which case? Yes, in the second case. And the balloon is, it is getting widened up in the second case, where there is more, we are filling more water in that glass tube, right? Very good. So in the first you can see that if we are having this much amount of water only, the balloon is only getting this much widened up. But if we are filling it full of water, so it is getting widened up more, right? So now students, what can you infer about the pressure relating with this image? What do you think? What is happening over here? Yes, you might be saying that pressure is being exerted by the water towards this ball, this balloon, right? Very good. And let me show you the another image. What is this girl doing? Yes, this girl is blowing up the balloon. And how the balloon is getting blown? Yes, with the air. She's filling it air in from his from her mouth to this balloon, and it is getting the widened up. And you might also have blown the balloons, right, in your birthdays or any parties that you fill air with your mouth. Okay, nowadays some instruments have come, like we can directly pump those into the balloon, but students, here what this girl is doing, it is using the air to blow this balloon. Okay, so now if I ask you that, if you have to infer something about related to pressure with the first case and in the second case, so what do you think? Yes, students. Very good, students. So if you are saying that, ma'am, some pressure has something to related to do with the liquid also, the gas also, the water or air, you are saying, you are absolutely correct, students. So basically we are going to discuss about now the pressure exerted by the liquids and gases. Okay, pressure exerted by liquids and gases, right? So students, actually the pressure exerted by the water at the bottom of the container, it depends on the height of its column, right? Do you agree? Yes. So when the height is more, students, as you can see over here, height of the water is more. So the pressure will be more in this case, right? Yes, very good. Liquids exert pressure on the walls of the container. Container, you can see that what is happening, we are filling up the liquid. So it always exerts the pressure on the walls of the container also. And the balloon is automatically, it's exerting pressure there. And gases to exert pressure on the walls of the container. So if we have a gas filled in a container or a liquid filled in a container, students, so what they do, they always exert pressure. Okay, always exerts pressure, like the gases also and the liquids also. And the pressure exerted by a liquid or gas in a container is transmitted undiminished in all directions of the wall of the container. So if we have the liquid and if we have, you can see the gas molecules over here, so they always, what they do, they exert the pressure on the walls of the container, every direction, the gas and the liquid. So that is why you see that when we are filling the air in the balloon, so air is getting the undiminished, spreading in all the direction, and the balloon is blowing. And same with happening with the case of liquid also, right? Yes, very good, students. So these points are visible to you now. It is they are visible, right? Yes. So let's move ahead. So as we have discussed now how pressures are exerted by liquids and gases, students. So you have to give examples from your daily life where you might have noticed that liquids and gases, they exert the pressure. Yes, you can think. Yes, you might be wondering that the gases which we have in our cylinders, the LPG cylinders at our home, so there also gases exerting pressure on the container or the cylinder in which it is filled, or the liquid, the water is filled in the tanks also. It is also the exerting the pressure equally in all directions in that tank also, students, right? And now in our coming class we will be discussing more about that, how actually the pressure is getting exerted equally in all directions by liquids and gases. Okay, so students, now it's your time to turn to answer this. Pressure exerted by water at the bottom of the container, it does not depends on the height of its column. So students, what do you think the answer will be, true or a false? Yes. So it will, this statement, you must be answering it as false. If you are answering it as false, you are correct. It is a false statement. And students, why it is a false statement? Yes, because we have just now seen that how pressure exerted by the water, it depends on the height of its column, right? Yes, very good, students. So now I am going to show you something and you have to observe what is happening in that. Okay. Sure. Let's go. Yes, students, so what have you observed in this video? If you want to see it again, I will play it again. Yes, students, so what have you seen? Yes, you might have seen a magic. And what was that magic about? Yes, that the magic man was filling the glass with the water and he was inverting it by placing a lid, but the water was not coming out. But in actually, does it happens? Yes, sometimes it happens, students. There is a reason behind what is happening with the magic which we have performed, because science has logic in everything. So here also the concept which is involved, students, is the atmospheric pressure. What type of pressure involved? due to which this is happening, it is atmospheric pressure, right? So students, what is atmospheric pressure? Because of the air pressure pushing upon the card will stay on the glass and the water will not split out, because air will be pushing it from the underneath of the paper, which is enough to stop the weight of the water from pushing the card down. Also, because of the air pressure, the card will stay on the glass and the water will not spill, because air also, students, exert the pressure. Air is all around us. We know that how the envelope of air is forming the atmosphere. So students, this atmospheric air is extending to many kilometers above the surface of the earth, right? And the pressure exerted by this air is known as the atmospheric pressure. So I hope you are clear with this. What is atmospheric pressure? How the air is exerting pressure, right? Very good, students. So now it's your time to turn to fill in this blank, that the pressure exerted by the air is known as dash. Yes, students, so you can write your answers in the comment section. Yes, students, so what answers are you getting? Yes, it is known as the atmospheric pressure. So I will write it for you over here. Yes, and students, what is the atmospheric pressure which we have discussed about? Yes, the pressure which air is exerting on the things like the objects. So that is known as the atmospheric pressure. Okay, very good, students. So now let's move ahead. So students, what have we discussed in our today's class? Yes, yes, today we have learnt a new concept related to the pressure, right? Very good. So students, pressure, under pressure, which we have discussed about the atmospheric pressure, right? And how the pressure is exerted by the liquids and gases also, right? Very good. So students, today we have learnt about pressure, its formula, liquids and gases exert pressure, and now let we are going to summarize our class with few questions. So students, what is pressure? Yes, pressure is the force acting on an object per unit area. Very good, students. And if I ask you that what is the formula of pressure? Pressure is given as, yes, it is given by the force per unit area. So students, this is a very important formula, that pressure is given by the force per unit area. So student, dash and dash exert pressure on the walls of the container. What will come in these two blanks? Which two things we have discussed that was exerting the pressure on the walls of the container? Yes, the liquids and the gases. So in this blank, what will come? Liquids and gases. Very good, students. So now the pressure exerted by air around us is known as, yes, students, what are your answers? Yes, it is known as the atmospheric pressure. Very good. So you can also note down side by side, because these are very important points. So students, the activity which we have seen with the help of that plastic tube or the balloon, that activity, what it proved actually? Yes, very good. So if you are saying that it proved that liquids also exert pressure, so you are very correct. So it basically proved that liquids exerts pressure. Very good, students. So now we are done with the recapitulation. Now it's time for you to do this homework. The first question, that a blacksmith hammers a hot piece of iron while making a tool. So how does the force due to hammering around the affect the piece of the iron? You have to relate it with the pressure also. And also when we press the bulb of a dropper with its nozzle kept in water, so air in the dropper is seen to escape in the form of bubbles, you might have noticed. And once we release the pressure on the bulb, the water gets filled in the dropper, right? So what is the rise of water in the dropper due to what? Is it due to the pressure of water, the gravity of the earth, the shape of rubber bulb, or is it due to the atmospheric pressure? You have to answer this. And one activity which you have to perform is that you have to take 4 or 5 plastic bottles of different shapes and sizes and join them together with small pieces of glass or rubber tube, okay, as shown in this figure also. And you have to keep this arrangement on a level surface, okay. You have to keep this on a level surface. In any one of, now pour water in any one of the bottle. Note that whether the bottle in which the water is poured gets filled first or all the bottles get filled simultaneously, okay. Now you have to note the level of water in all the bottles from time to time what is happening. Then explain your observations by writing in your notebooks. So students, that's all for this today's class. Thank you, and we'll meet in our next class. So thank you, students. You can recall all these concepts which we have discussed at your homes also and find out the your homework and perform this activity.